Surf. I'm your chief internet evangelist, but today I'm just going to be introducing our speaker, Donald Clark. But let me explain the purpose of this afternoon's session. Donald and his colleagues are here from New Zealand, and they're very interested in advanced networking. Their primary focus has been in the academic arena, but as we all know, academic applications and networking have leaked out into the general public. If that weren't so, Google wouldn't be here. Our founders leaked out from Stanford University and started this company. So a purpose is to have a discussion. So although Donald's going to have something to say about what his organization has been doing, in fact, it's intended to be much more interactive. And so please don't be shy about raising issues and ideas and reacting to the things that we're talking about. I think, Donald, you'll accept an interruption at any time. Let me tell you a little bit about Dr. Clark. He was originally a chemical engineer from Edinburgh. And he says in his informal resume that he failed at being a chemical engineer. So then he became an IT, information technology and computer consultant, writing C code for Price Waterhouse. And he says he failed at that too. Now, I'm sure this is by your metrics, Donald, perhaps no one else's. Then he helped start up Ask Jeeves in the UK as a sales engineer. So clearly he's drifting away from his roots at this point. He claims he failed at that too. But then went on to Booz Allen Hamilton, a very large and well-respected consulting company, doing business in information technology consulting. And he said he did okay with that. And then, for reasons unspecified, he moved to New Zealand. I presume wasn't a consequence of having anything happen at Booz Allen Hamilton, and worked for the government. So that's quite a shift from his early roots to from private sector into government work. First for the Treasury, and then later for the Prime Minister. And by the way, the Prime Minister of New Zealand is a force of nature, as nearly as I can make out. I've met her on occasion, and very, very... sorry?
A result of nature.
Yeah, incredible. So his consultation for the Prime Minister involved telecommunications, digital technology, science, and transport. And then as of June of 2006, he became the CEO of an organization called REANNZ, which is the Research and Education Advanced Network of New Zealand. The project of which he'll be talking about today is called CAREN, the Kiwi Advanced Research and Education Network. It is, in some respects, the analog of the American National Research and Education Network, which in fact led to some of the commercialization of internet technology. We have analogs here in the United States now with the National Lambda Rail and with the Internet 2 project of the University Consortium for Advanced Internet Development. So Donald and his colleagues are here to learn from us the kinds of issues that we see driving network technology development, what will push the edges and the limits of what we can do today in networking. So without further ado, Donald, let me ask you to engage in the conversation.
Thank you very much indeed. Thank you. Thanks for having us. There's a certain irony, I think, as Vince said, is we came over here trying to tap your knowledge and experience, and suddenly we end up here presenting to you. So if we can mirror that as much as possible, that'd be wonderful. I think before I sort of I get into this, I've tried to have as few of my own ideas as possible in talking to you today, and really hoovered up a lot of what's been going around in our community. A lot of people we've got to mention, and they'll get a mention in the source material as we go through, but in particular, there's a couple of news lists, one run by Bill Santarno of the Canadian network Canary, and another one which is called ArchieCon, which has some quite good thinking that goes on. So I found those lists particularly useful to keep up to date, and I can give you those details if you're interested yourself. So it's probably worthwhile, though, starting with a little bit of context, right?
This is why you came to New Zealand, right?
This is not why I came to New Zealand. I mean, New Zealand is a country which is gobsmackingly beautiful, and it's basically full of nutters who devise new ways to kill themselves in extreme sports. Okay? Physically, this is the sort of territory that you have to put fiber through. Okay, so it's not a brilliant country in terms of its natural topography for supporting people laying fiber. Okay? It's also not the country where if it's a little bit foggy at your local airport, you get diverted to in your plane. Okay? This is a hemispherical zoom out from Google Earth. Here's Wellington. You can't see North America. Okay? It's 11,000 kilometers to get to San Francisco from Wellington. Okay? Across the US, it's 4 and a bit. Okay? We can just about see Australia, this sort of small island over here that, I don't know, some stuff goes on there we don't care about. Antarctica is just about as close. Okay? So again, the challenge you've got here is our network boundary isn't the edge of our country. Right? Our network boundary is Sydney and it's Seattle. Okay? So we have an enormous networking challenge, right, just to get out of the country to internetwork with the rest of the world. Okay, now a lot of that thought drives, a lot of that sits behind our thinking in New Zealand. Here's some stats, some of them a little bit lighthearted, but I wanted to compare New Zealand versus California, again, to give you a sense of the context, the environment that we're going to be coming from. We're about half, maybe 3/5 the size of California and New Zealand, with a lot fewer people.
Sorry, I've already got down to the fourth.
You're too cute. There's a lot fewer people, and we've got 10 sheep each, which is pretty good odds. Okay. I was trying to think of the right metric for California, and the only one I could think of was venture capital firms. And to some extent, again, this underpins our economies. New Zealand is an agrarian economy, right, based on sheep and on meat and on milk production, and increasingly some other things as well. And I really think of California. I think people think of a capital economy, okay, an economy by applying capital in smart ways to new technologies. GDP-wise, New Zealand trucks along about 100 billion US, and California's about 1.7 trillion. And in the purchasing power parity, you can see that the GDP per capita of New Zealand is significantly below that of California's. Okay, so that's on a PPP basis, not a nominal basis. So again, there's a context here of a disparity of wealth, a challenge with networking, a challenge in economic and fundamental base, what drives the wealth of New Zealand coming through. We do have a wine industry. It's not quite as big as California's, but there are some fantastic New Zealand wines. So when you do get to come and see us, you'll feel right at home. And the last comment there is that the one thing we do punch above our weight on, thanks to Peter Jackson, is we've 20%, so 2 out of 10 of the world's biggest ever grossing box office films were filmed in Wellywood, okay? So there we go. That's a bit of a comparison, but hopefully you've got a reasonable picture there of New Zealand. Let's talk a little bit about Karen before I get into the challenges and opportunities. I'm not going to go through all of this, but very briefly, we've got a big old 10 gig Lambda around the country. We try and keep everything at layer 2 as much as possible. So we VLAN and we switch everything to keep it fast. We really just have one router, but I mean, we've got 2 of them for redundancy, but we just route between VLANs. Our POPs are neutral, so we have neutral interconnects. That's really critical for us. But we lease the wavelength from a domestic supplier, and we lease our international capacity from Verizon. So they provide a fully managed service for us internationally. We've got an STM1 to Sydney and STM4 to Seattle. There's this metric. You think, well, what the hell is that metric? Well, one of the European NREN, National Research and Education Network organizations, which is the European one called Terena, they have a benchmarking survey. And what they do is they try and sort of have this who's got the biggest competition, right? And they come up with a metric which is you times your capacity of network by the size of your kilometer stretch. Okay, so we work out at around 38 million megabit second kilometers, including our links to Seattle, including our links to Sydney. That actually places us around 4th or 5th when compared to all the other European networks. So we're maybe not technically the most advanced. We've maybe not been around for that long. Karen itself has only been lit up since December the 15th last year. So the network's just about 14 months old. But in terms of physical size and challenge, it's significant. We're already getting in excess of 10 terabytes per day on cumulative port count traffic. We're not quite sure how else to measure it. So people are starting to use this thing. Our challenge here is really how do we go forward? What does Karen 2.0 look like? What are the challenges we're facing?
Question is,
Yeah.
is this strictly accessible? Let me find out whether
We got a mic? Here we go. Here. We turn the mic on?
Do you need the mic in order to capture on the, yeah, okay. So it's Vince Cerf, and the question is whether the system is accessible to any other than the academic community.
Our mandate is to connect the research and education community in its widest sense. So that includes schools, libraries, museums, teaching hospitals. It also includes private sector organizations which are doing research with our members.
And this is research in the IT sense, or is it more broadly? So it could be bio-research,
Absolutely,
or it could be astronomy.
So Fonterra, one of our big domestic milk and cooperatives, does research, they're eligible to connect to Karen for doing that.
So the implication of that is that the applications that might find themselves on this network are drawn from a very broad range of R&D activity and could involve very large data sets in the bio world, astronomy, physics, and so on. Could have very significant demands on movement of data or storage of data.
Absolutely. That's one of my challenges, actually.
Okay.
Yeah.
If anybody else has questions, holler and either use the microphone up there or grab me or something.
I swear. If anyone can't understand me as well, then wave your hand and I'll try and speak in tongues or something. Briefly about me, sort of Vint covered it really, but my first computer I'm very proud of was a ZX Spectrum 48K. Does anyone remember ZX Spectrum? No? Warwick does. That's because you're from Britain. No one else does. But yeah, I got actually into computers doing my chemical engineering, more so in some of the nonlinear modeling systems that process engineers have to do. And there's our beloved Prime Minister that Vint was mentioning. That's a really good picture of her.
Yes. Okay. We're not going any further.
We're not going any further. Finally, some context around e-science and e-research. Okay? So when science started, okay, I guess thousands of years ago, it was a descriptive, sort of empirical option. We then moved on to, I guess, theoretical science, so where people actually said, okay, well, I'm going to create a law, Maxwell's laws or Newton's laws, and we're going to actually use those and predict the future because of it. Simulation, I guess, kicked in middle of last century, and people started to say, well, actually, I can take these complex phenomena, these laws, and I can model them, and I can start to see how the real world might act without doing those real experiments. And I think today, really, there's a picture of Jim Gray there, I guess the late Jim Gray. Science is very much data-centric. Okay, so whether you're creating data from your experiments, you're capturing it from your instruments, you're generating it by simulations, you're generating it from your sensor networks, the vast majority of science is getting ever more data-centric and data-intensive. So it's creating a set of disciplines, a set of challenges for researchers, which says, okay, how do I work in that environment as a researcher? Okay, so just comparing, say, a researcher today with a web user today, and let's say this is Mr. Average or Mrs. Average researcher. They're doing things, they are sharing, but it's usually quite asymmetric, okay, and it's usually not that pervasive. They are collaborating, okay, and they are starting to share their ideas of how they're doing things, but when you compare it to some of the new paradigms we're seeing emerging, and it's a bit messy, will any of these be successful in the web world? We don't know, but there's a lot higher sense of instantaneous collaboration, a lot more sense of data coming together more fluidly and moving across boundaries more fluidly. So I think this model, a traditional researcher has this model of being at the center, being the hub. I'm going to do an experiment, take the data, give the data to something else, process it, take it back, think about it, talk to a colleague about it. And I think there's that sense of a researcher actually having to stand back and somehow allow the data itself to flow between those elements more easily and be the conductor and the orchestrator rather than the hub for some of that data. So those are some of the background challenges as well for e-researchers in this data-centric world. Briefly, what I'm not going to talk about today or try and bring up for discussion is the culture change, the funding, those sorts of aspects associated with e-research. Okay, they are big and they are significant, but I'm just going to try and stick to the hard and the soft engineering challenges. Because a lot of these things, a lot of the culture change things and the funding issues are very country-specific and very culture-specific as well.
Another question about hard and soft engineering. For you, soft engineering might be things like user interfaces or application space where you're trying to figure out, well, how do I make this particular task easier to do, more automated data discovery and so on?
Yeah, that's right.
Okay, thank you.
And hardware, anything probably from sort of middle network layers down to the boxes and the fibers. Right, so here we go. I picked 6. I picked 3 opportunities, 3 challenges. I mean, to some extent, challenges and opportunities are a bit yin and yang. So there's elements of both in both. But these are our challenges really today that I think are stopping us accelerating forward. Okay, so that's identity and access management, it's data curation, and it's local access. Right, the pervasive local access, last kilometer, last mile challenge. On the opportunity side, I think these are areas where we as advanced research and education networks, as academic networks, have a real chance to influence the wider community, both the commercial space and the public space. okay? And I think that's around resource efficiency. So we're environments in which we can get better at sharing the use of people, of data, physical equipment, and be more energy efficient. I think we're also a space where we have a less challenging relationship at times, or a less tense relationship with some of the market players, and we can drive some innovation in terms of the solutions the market wants to deliver. We can drive some innovation in terms of government public policy, and we can drive network innovation. So there's a chance for academic networks, just as ARPANET originally did, and as we've seen with some of the projects that are coming out of the US and Europe just now, to try and innovate in the network space. And then finally, one of our key goals, obviously, is to support New Zealand and support that in generating greater innovation outcomes forward, and sharing our culture and our stories with the rest of the world.
So already, now, how do you want, I have a whole bunch of reactions to these 6 challenges and opportunities. Do you have more that you are going to present before you dive into a discussion
I was
of these
about
things?
to start on each of these, so.
Okay.
If you want to.
No. Why don't you dive in, and because I have specific reactions, especially in items 2 and 5, and maybe 6.
Okay. Right. Great. Does anyone else feel there's something particularly missing there, or they might want me to try and cover, or just yeah?
Wait.
Hang on.
If you want to be on the record, you need to talk into this thing. Are we live? Go for it.
You talked about the network primarily being a research network,
Yeah.
right? So how well is the country itself linked, especially your point 5 where you're saying driving the market?
Yeah.
So unless the research world and the private sector really join hands, how are you going to drive the market and stuff like that?
We can drive the market in terms of telecommunications products. Now, I'll touch on some of this later, simply by forcing the purchasing habits. And because we're not a big, scary, cannibalistic, we're going to take your revenue away, you actually find when you go to market that the vendors are able and willing to do different things. So we went to the market and asked for a 10 gig least wavelength of light. Never done before in New Zealand. Right? Just push the market so far in terms of delivering that. We're seeing already now some of that type of service being offered by the telco that provided it to us into the commercial marketplace a couple of years later. So I think it's just been able to say, we're not a scary competitor. It's not about cannibalizing your traffic. But if you work with us, we're going to want different stuff than you're delivering just now. So you're not, and this I'll go into more detail. It's a good question. Okay, identity and access management. So here's this researcher at the edge, being the conductor, not the laboratory, but the collaboratory, as somebody sort of termed it at one point. And there's lots of middleware, and there's lots of software sort of governing all these different unit operations of research, I guess, rather than chemical processing. So how does that happen? Well, that's great, because I can send some messages here, use some distributed resources, and that's all very good. I want to pass my data around. But to access the data to share a resource, I need to identify myself, all right? I mean, we don't live in this perfect utopia where there's commons and everything's available to everybody all of the time. So out of that becomes identity and access management, the ability to be able to say, I am this person, have that asserted, and I have access to the following resources that you're offering. Okay? And that's a really important thing. And traditionally, that's been done by having multiple logins.
So one important distinction here is to be made between identity and privileges.
Yes.
Those should be distinct. Yes. The fact that you've identified yourself doesn't necessarily imply any particular privilege, and different privileging systems could exist concurrently with the identity system, and the privileging system says, please help me validate the identity of this party before I then decide which access they have and what actions they're permitted to take. Yeah. You said here that it's the number 2 issue in Australia. This is the number 2 issue for whom? For which?
That was a survey of the university IT directors last year or a year and a half ago.
And what is it that's driving it as an issue?
I think it's been driven by 2 things. It's been driven by science becoming more expensive and the cost of science becoming more expensive, whether that's access to a public data source or a commercially provided data source, or it's buying a piece of equipment. And at the same time, your funding stream isn't going to the same extent. And collaboration's driving it as well. So internationally, people are collaborating a lot more. And as people start to exploit some of the new web-based tools or, shall I say, more instantaneous delivery mechanisms, people are just getting fed up with having to assert who they are every time and then try and secure access to a resource. So there's a tipping point coming where the pain of having to manage multiple assertion and access privileges is sort of driving this now and saying, okay, every day, if I want to set up a custom access across campus to allow you to tap into this database, that's a drain on IT resource. If I can have a framework that we've already agreed.
Okay, so there are interesting implications. This is important to Google. For example, the Wikipedia, which is sort of unattributed, has been subject to some complaint about the fact that you don't know who supplied the information. And we made an attempt to deal with that problem using a system which we would have authentication and attribution. Sorry?
Is that your new
This
crawl?
is the null. This is the null idea.
Yeah.
But this same thing shows up in the commercial context as well, where you want to authenticate yourself to some authority, which will then quickly validate, because it's a computer-based interaction, quickly validate you to other parties, third parties. This is always the trusted third-party problem, which invariably shows up. But there's also a hijack technical challenge here. Once you've authenticated yourself to some third-party system, which is then going to be used to authenticate you to other services, you need to make sure that the party who made the authentication is still the one that is interacting with the service that has been authenticated by the third hand. And in order to do that, you almost have to have some kind of a cryptographic method for inhibiting an attempt to hijack access. And so somewhere buried in all of this is a strong, I believe, a strong dependence on high-grade cryptographic support.
Could be. Yeah. So, I mean, let's talk a little bit about some of the things in our research and education community that we're seeing. I believe that a lot of the technicals, certainly in terms of technical protocols, are largely solved. There's a convergence around SAML2, security assertion markup language. Okay? We're also seeing that convergence not just from the academic side, but from the private sector. The Liberty Alliance has adopted SAML2, and it has announced in December '07 that it's actually certified its first set of products which are SAML2 compliant. Okay, and a lot of these are actually identity servers from middleware providers, BEA and Sun and whomever. So we're seeing some pretty good alignment. Okay, the great thing about the SAML2, and it's integrated in something called the Shibboleth implementation for the R&E community. It's a very common implementation. Shibboleth came out of an Internet 2 project. Is it's federated. Okay, you have to set up your levels of trust, but what it does is it says, well, my host institution says, yes, I am me, when somebody asks. But it only distributes to the asker the minimum required set of attributes to allow me to do what I want to do. So it has quite important data privacy protection issues as well here. Instead of me telling several people all about myself, okay, I can control more tightly my personal information, okay, my personal attributes. And if I want access to a resource, then that resource says, well, I just need to know if they're a researcher there. Or I need to know maybe if they're over 18. Or I need to know if they're part of a particular program. So it can request just specific data points, and once you've, I guess, genuinely authenticated who you are, you have much less personal data transfer and the credential distribution that goes along with that. So this is why, and Samuel too, it's interesting to talk about the government stuff. In New Zealand, the government is implementing a government single login service for web-based services, and it's converging on SAML 2 as well as its architecture. So across the education space, across the R&E community, and across government as well in New Zealand, SAML 2 is the architecture that's being used. I'm not quite sure of the cryptographic actual implementation standards.
There is another potential hazard here. A single identity can be bound to essentially everything you do. And so people who are concerned about privacy worry that this sort of single sign-on leads to privacy abuse. And especially, you mentioned the government. Of course, for many people, not just in the US, but elsewhere, there are concerns that the government knows more than you want them to know about your everyday activity. Has that risen to visibility on your radar screen?
Yeah, within the government, now I'm on thin ice here because I'm not entirely sure what's going on, but within the government, they don't actually store, they've got a setup where they don't store your ID. They actually just authenticate your password. And we can get the architecture references, but they don't actually store your profile. So I'm not sure whether that's stored at whether that's distributed or whether it's stored personally, but they have an architecture where in New Zealand, because we have privacy laws that say you can't do this sort of thing, they have some architecture that allows for validation of your identity, but doesn't store lots of information about you. And I think it's almost like a login name versus password authentication. It's they've thought about that, but I don't have a great answer for that.
I think maybe after this talk is over, I'd like to follow up.
Yeah, we can look at the website. Yeah. So while I think we've got some of those technical convergence challenges solved, and people generally know where they're going to be heading for, there's still a lot of business process challenges. Okay, the levels of trust that you have to federate at. So just because, somebody's asserting the fact that I am who I am doesn't mean that I necessarily trust that person. Okay, or there are different levels of trust. Getting a passport and asserting that somebody is someone so you can give them a passport is a quite different level of trust than simply allowing them to log into your newspaper online. So a lot of the stuff there has to be worked through. Again, legislation comes in terms of alignment domestically, but again with international requirements. More and more, we're seeing disparity between international data regulation, data privacy, and data management regimes provide some quite significant stumbling blocks for cross-border identity and access management. How do you do it? That's a big challenge as well. The US has taken more of a carrots approach and a cajoling approach. It has the InCommon Federation, incommon.org. The UK, because it has more of a top-slice funding model, has been more of a benevolent dictator and just says, we are going to this, and here's $50,000 to help you, tweak your systems. Let's just get on with it. I think it's an open book, quite where New Zealand's going to end up. Right now, it's taking a bit of a fact-finding encouragement approach. And this is my last slide on identity and access management, but I think we've got to mention OpenID as well. Where does OpenID fit into this picture of the SAML 2 architecture, the institutional authentication? That's just some Google Trends information. You can see that suddenly OpenID has become very popular, at least among searchers in the last little while. To me, it's quite different, though. OpenID is a personal level shared ID, shared login service. Okay, your SAML 2 shibboleth implementations are institution-centric. Okay, so I can go to any site. I can set myself up as an OpenID provider. It's just a way for me to not have to log into lots and lots of sites, and hopefully everyone recognizes my URL that I'm providing as my identity assertion location. An institution-centric approach has a quite different level of trust associated with it. Okay, so they're coming from different angles. One is simply a nicety to avoid having to log in lots of times, and I think Yahoo at the end of the month is becoming an OpenID provider. So hopefully my Yahoo ID is going to let me access lots of other things without having to re-log in and re-register at lots of other sites. But it's not going to suddenly let me access academic resources or trusted resources through a shibboleth federation. I think the likely outcome is we'll see some sort of integration between the two. Possibly that I can go to an institution in the future, I have my OpenID, and I can temporarily federate my OpenID or associate my OpenID with the institution. An institution, if you then like, becomes a temporary super level trust provider for my particular OpenID. That imposes, again, security challenges and business rule challenges, but something like that might be an outcome as we go forward.
I know you're halfway through here, and we're only on the fourth slide. Just one thought about identity here. I think that there's a balance between the willingness to accept another party's authentication, the risks associated with accepting it, and the liabilities associated with, let's say, inadequacies of authenticity. And so from the business point of view, we need to find ways to balance those. But if you back up a couple of steps, we also need to define standards for authenticity. What steps did you take to authenticate an individual? And in the US, for example, every state in the union issues driver's licenses, and they are accepted on a national scale for personal identification for certain purposes. And there's an assumption that's made that every state in the union has applied minimally acceptable authentication mechanisms and procedures, whether they have or not. That's the assumption. So I think there's a very interesting business analysis that can be taken here, balancing liabilities and risks.
Yeah, that's a good point. I think in New Zealand, and it may be internationally, the education sector has set out parameters for about 4 or 5 layers or levels of trust. And they've done some of that definitional work, but I haven't seen a good example of the business process risk analysis. Okay, so that was identity and access management. Sorry for maybe skiting over some of it, but there's a few other things to speak about as well. Data curation, this is a biggie. Okay, to some extent I answered this question a little bit earlier when Vint asked something about what was driving these, but this was a slide that Rick Stevens at the Argonne National Lab over in Chicago put up at one of our conferences last year. And he called these the super trends, okay, that were driving changes in the way science happened. And they have an impact on data, all of them, particularly the first 2. He pointed out that experimentation has been increasingly done by high-throughput robotic systems. Okay, so the amount of data that's being chucked out is almost exponentially increasing, and it's increasing almost in ease, at least linearly, increasing in ease to actually create that data. So what we're having there is a data volume revolution. Okay, there are significantly large and ever amounts of data being produced. The complexity of problems is such that it's driving us towards interdisciplinary science. I think there's also a funding constraint there that's driving us towards that. So people are now having to operate, with larger data sets, but across larger groups of people, more complex organization and team boundaries. And that puts pressure on your data to be accessible in different ways. It puts pressure on your data to be shared and curated and managed in different ways. The last thing I think has, to some extent, an impact on data, but the point being made there is that we can actually fundamentally change some of the research and some of the data generating activities we can do by moving from the mesoscale down to, say, the microscale at benchtop experiments, especially in biogenetics and bioinformatics. And that actually what we could be doing there is saying, well, we've worked on all these data sets to date. Forget it. It's easier just to replicate them and create a whole new data set or a whole new data foundation for our research area. So there's a few super trends that Rick points out that are sort of driving science, and all of those have data implications. So the first one, lots more data. Okay, how much more data? Well, this is Janet's. It's the UK network, and it's pumping out about, 3 petabytes a month outbound traffic. That top graph is from the Terrana study, so that's the European networks, and that's annual traffic growth, and it seems to be stabilizing currently at around 50% per annum. Okay, traffic growth on the European academic networks.
I know we don't want to get tangled up in a particular chart, but I'm fascinated by the apparent regularity of the depth in the traffic charts. If you look, and you can see these big. What is this all about? Is this Christmas time?
Yep,
or something?
I think that's academic
It's
holidays.
or the holidays.
Yeah.
Okay, all right. Everybody stops working.
The computers still talk a little bit.
But computers are never supposed to stop working. There's something wrong here.
I mean, there are areas of research that are growing at more than 50%. Okay, so the LHC, the Large Hadron Collider, is going to chuck out gigabit per second feeds, so that's 86 terabytes a day. Okay, you're already doing experiments that are chucking out, easily 2 terabytes a day for some biosequencing stuff. One of the reasons I think that this growth here, this 50%, doesn't necessarily match the fact that, well, to some extent, the commodity internet growth, because we've been ahead of that. I don't think it matches that 100% of some of these experiments because, to some extent, it's brought up in the average, but also we're seeing the early phases of people setting up separate private networks, which don't get measured by the big IP pipe. So the LHC data is going to sit on separate optical paths. Okay, and I suspect that a lot of this data measurement, we're simply not going to be measuring almost traffic volume in the future. I think one of the traffic volume measures we'll be doing is simply how many point-to-point dynamic circuits do you have on your network? Okay, how many lambdas do you have provisioned? And we're not really going to care whether somebody's using that lambda at full capacity at 10 gigs, at 40 gigs, or whether they're using it at 1 gig, because it's just easier and cheaper to give them a lambda, right? We don't worry with MPLS, don't worry with quality of service, you just provision them a wavelength, okay? And what you'll do then is you'll have an impact on your traffic volumes, and we'll switch from this paradigm of how full is the network, what's the contention ratio on the network. You just move away from that. So there's some potential there, but certainly there is lots more data being created. And that data is happening in lots more places as well. Okay, so the web's there, and then the younger generation of researchers are starting to go, oh, it's great, I can share my business processes and put my experiments up and do a public sort of, announcement of my science online and put some data up to support it. I can run a grid on my grid in the UK, or I've got a virtual research environment. There's lots of these things coming up now, and that's wonderful. Okay, but that's a real headache if you're trying to manage your scientific data, right? It's wonderful to share it, but that sort of Web 2.0, Science 2.0, science as a service or science tools as a service idea creates real headaches if you have to curate your data. And the ownership, we talked about that international collaboration as well. Who actually owns the data? I mean, organization might say, well, it's my IP, and I have to own it, it's on my server, but suddenly data sets have been smooshed together, okay? Or maybe I only have ownership for a period of time. And I think the stakeholder base around information sets is getting increasingly vague and increasingly diffuse. And there's a real challenge there in terms of ownership as well when you come to data curation. This is wonderful. You won't be familiar with this. I hope you won't be, otherwise you need to get out more. This is the New Zealand Public Records Act. Legislative impacts can have a really, really major driving force on what we do in this space. The New Zealand Public Records Act 2005 is quite advanced legislation in this space. It says you have a requirement as a public office, and that includes universities, to maintain full and accurate records for at least 25 years. If you want to get rid of any data, right, any record, you have to get permission from the chief archivist. Okay, so suddenly now you can't just shirk your responsibilities and say, oh, we deleted that, we threw that server disk out, we didn't need that data anymore. And sorry, you've got to convince the chief archivist in New Zealand that you don't need that data anymore. Okay? On top of that, in 2010, they're starting audits of all the public offices to make sure they're compliant with this. Okay, so this is driving huge compliance headaches, and I don't think the research sector in New Zealand's actually sorted this out. This is a challenge for us today. Okay? There may be some ways to help drive solutions for this, but fundamentally that really puts a fire under the data curation issue. And here are some of the challenges. What role do people have? Okay, what responsibilities do I have? What's my role to play? And it could be different at different times with different data sets. How do we prioritize what to store? What data elements, Even what sort of order to try and store things in? Who makes those decisions? How do we bother collecting it? Do we have incentives for the researchers? Because right now they're probably not getting paid to spend the time it takes to actually curate and store and put metadata around some of this stuff. What's our policy on what do we keep and what we don't keep? Because if we allow people to make their own judgments, which is kind of what it is just now, you end up with quite significant inconsistency. The actual technicals of retaining and managing it, very hard, very expensive. Okay? How do we keep access for it? How do we make sure that format shifting and data degradation doesn't occur over 25 years? I can't open my Microsoft Word 2.0 documents that I wrote some of my final year stuff in. But we've got to keep things for 25 years. That's a problem. I think our community around the world is starting to address some of those challenges. I think it's fair to say that probably the UK and the US are much further ahead. The UK, for quite a while, has had its digital curation center. Some great stuff here, some great education, some best practice tools, how to audit your data, how to pick what standards to use. And they're sort of running a UK data archive, but they've got lots of repositories. They're not going for a monolithic, we'd like all your data, please, and we'll take care of it for you. So they've taken more of a federated, disaggregated approach to storage. Pluses and cons to that, I guess. The US recognized back in September '05, the National Science Board said this is going to be a problem for us. And they've actually got an NSF proposal out there just now, that's the number of it, for DataNet. And they're looking for submissions around this. Limited initial scope with a real practical focus. So I think the US is heading down more for, a big bucket for everything. We'll see how successful that is when the proposals come in. The Australians have picked it up recently. They're investing nationally in a national data service for research. New Zealand really hasn't done anything yet on the REANNZ side. It has funded a national digital heritage archive, but that's really from a library perspective. So it's about deposits of library books and web scraping. So it's not really tackling the research side. So we're underway, but I'm not sure, given the exponential rate of volume that data is increasing at, we should feel at all comfortable.
Could I just weigh in on one point here? I've concluded that we have what I'm calling a bit rot problem. Basically, it has a lot to do with the ability to understand the data that we've archived. The formats will change over time, and the software that knew that format may die.
Yep.
And we're going to run into some serious challenges there. And afterwards, I'd like to follow up on that.
Huge. I've got a great example from the BBC. BBC back in the 1980s did something called the Doomsday Project, where they went around lots of schools and took snippets of our life in the UK, and they put it onto these laser discs. And they were pretty much a custom format with custom machines that ran against a BBC Micro, and you did this particular hard disk player. And I think there's now only one machine left that an enthusiast kept that can actually read those discs and play them back in their original format. So yeah, and that's been 20 years.
Incidentally, the problem here is that you have to preserve the software that knew how to deal with the application and the data and the metadata. Then you may need to preserve the operating system that ran that application. Then you may need to preserve an interpreter of the hardware that ran the operating system and so on. After a while, it's starting to look like you need the kind of cloud computing that Google has been pursuing in order to maintain the ability to retain access to that data.
Yes, yeah. And is a virtual machine running, is that a valid replay of the data? Yeah. Okay, local access. This is challenge 3. I don't know if anyone here has a particular focus on physical networks, but for an advanced research network, it's very front of mind all the time. It's great having a 10 gig backbone. It's not so good if you can only get it into a school at 2 megabits per second over DSL line. Okay, so it's just a fundamental problem. We probably face it more than anything. Broadband wireless is improving. Okay, that's great. This is a map of Vodafone's 3G coverage, HSDPA coverage around Wellington. I guess the challenge is you still need more fiber in the ground, because the faster your wireless speed, the further out your fiber backhaul needs to go. Okay, depending on the frequency you're using. So there's no way of getting around it. Advanced networks are obsessed about fiber. Right? Wireless, great for some schools, great for within the campus, not good for us for anything else. Okay, it's fiber. But the marketplace also has quite a long, the marketplace is critical for deploying that fiber. Okay, absolutely critical. This is an OECD graph, and it's a range of broadband prices per megabit second. Okay? So you can see that New Zealand actually has some great value broadband. Okay, this is on a PPP basis as well. That's actually, that figure there is driven by a cable provider that has a couple of niche geographic areas where they've actually put coax and fiber cable in. Okay? The reason we've got such a large spread of pricing indicates a lack of competition, and at the high end, this is the incumbent slow DSL service. Okay? So the US doesn't fare brilliantly, but it's got a more competitive market. It's got a narrower pricing range. Okay? But you can see the US is well behind some of our best services on a PPP basis, and you're well behind other countries as well. So I think this, to me, this is a great summary slide of how effective your market is at delivering fiber.
I'm sorry, I'm not sure I'm understanding how to read this. Is the
That's top to bottom.
the horizontal axis is the data rate range?
No, that's your price. That's the range of prices on a logarithmic scale. So from $2 up to $38
I see. Okay.
of service offerings in the marketplace.
What's the? Oh, okay.
dollars,
But
yeah.
it's a logarithmic scale. Okay, got it. It's that's a little hard to.
Interesting
the
scale, right?
interpretation of that chart is a little hard to.
I sort of reckon that the narrower that is, the better your competition.
Yeah.
The further that way it is, the cheaper, so the more
Understood.
fiber you've got.
We don't have a good competitive environment in the U.S. right now for
No.
broadband either.
Yeah. So this is my view of what's happening globally in the world in terms of new fiber economics, for want of a better term. This is the an inverted pyramid that goes from the physical networking layer, so ducts, cables in the ground, okay, all the way up to services. You want to have as many people being able to compete on the service layer as possible, because that's where most of the innovation is happening, okay? That's close to the consumer, that's the exciting part of things. Okay, the turnover there is 12, 18 months and less, okay, in terms of new services, which you guys know very well here. This is the lit network part, 5, 10-year cycles, depending on how close to the edge of the network you are, okay? But less room for competition, less economic potential for significant competition, especially in small marketplaces like New Zealand or in regional towns and cities. At the physical layer there as well, ideally from an economic point of view, you don't really want to have competing physical infrastructures. If you can find a way to avoid competing physical infrastructures and still get all the access to the services up above at a reasonable price, then that can be beneficial in terms of minimizing the overall investment and duplication of investment in your country. The challenge I guess we've got today is that with an incumbent telco, they see a slice like this. Okay, so they have a limited amount of service innovation, and they have to drive a return on capital that's heavily weighted towards this end across the whole thing. So if you see here, the capital requirements are quite different. This has got a very low entry barrier. You buy a server, you stick it up in your garage, you get a payback in 2 years, hopefully you become really rich. Okay, you get a high ROI. Down here, you're looking at a 25, 40-year asset life. Okay, this is utilities, pension fund investments, right? This is, less than VC investors, right? This is sort of short-term VC work. So the different capital requirements, the different network layers, right, really engendered specialist types of capital coming into them. But when you have a vertically integrated monopoly, right, they try and capture the value by taking a position on the physicals, which is very hard to untrench. But what it does, it just limits competition, okay, and it limits the returns.
So we have an absolute terrible problem in the United States in this area. We have the net neutrality arguments in the U.S. and the non-discrimination arguments have fallen on deaf ears at the Federal Communications Commission and the Congress, with a few exceptions. In your country, I know personally about some interactions that led to a more enlightened view of opening up access to the physical facilities. But in the United States, it's been declared that there are no layers and that it's all internet service. And that leads the physical owner to inhibit competition by interfering with others who are trying to provide value-added services. It's really very, very bad.
There's been some high court rulings on that, haven't there, as well, in terms of that definition?
By definition, the internet does not have any communication capability in it at all. They moved it to a portion of the Telecom Act, which does not include any of the common carriage rules of normal telecommunications.
But Europe's getting that.
Yes,
the Netherlands,
yes.
France,
in fact,
Sweden,
Vivian Redding
Norway,
is very aware of
UK
this,
to some extent,
as is your Minister of Communications.
Yeah. So here's my essential solution elements for arriving at that sort of model. First thing you need to do is unbundle your IP Ethernet connectivity from your commodity internet service. Okay, it's fundamental. Karen doesn't provide commodity internet, that's a service. Okay, if you want to go and get it, you go and buy that as a service. You want to see some routes that go beyond the immediate edge device on that particular network, that's a service. Okay? This may be a subtle point, but I think it's pretty fundamental. The second thing is you need to coordinate your investment in that fiber to the curb, fiber to the house layer. So whether you take that on as a benevolent dictator again, you've got a local monopoly, maybe a utility that's regionally owned or is owned by the community. Happens quite a lot in New Zealand. The local regional councils often own the energy lines companies or the water companies. Use them. Whether you end up with a regulated over-the-top service provider or potentially competitive over-the-top situation, the telecommunications company, the traditional incumbent telco has been disintermediated quite quickly. Okay? You look at energy companies, entertainment companies, so TV and all the rest of it, health insurance companies, they're the people who are actually driving value out of having higher and faster connectivity speeds. Okay, so they have a chance to come in over the top and extract the value out of the telco service provider, out of that commodity internet connection. I think, in coupled with those, you could also look at doing some geographic or temporal concessions to that fiber co to sort of say, okay, we're going to allow you to make 20% or 25% returns for the first 5 years. We're going to accept that as a trade-off for you making a significant capital investment. But we're going to regulate you after that, or we're going to let you compete after that. I think you have to look at a range of finance options to the end user. So me in my house, okay, maybe I want to share the capital costs of that. Maybe I want to dig up my garden and put some fiber across to the nearest, connection node or splice point on the street. Maybe if I sign up for 5 years for an energy service or a health insurance company, they might, put the fiber in that last little bit. Or there's a public subsidy option as well. Okay, there's a number of options there. I think we have to explore those things. And I think also end users becoming owners and ideally controllers of those last few meters. Okay, the capital requirements, the payback of fiber changes where you are on the chain. The core networks, really clear, easy payback model. Traditional telcos can do it already. Municipal networks, local, regional networks, again, quite different payback economics, but the sort of thing that municipal bodies can get into validly. Maybe the last 100 meters or the last 5 meters off of fiber, I'm the only one that genuinely sees the payback, possibly by the house value increasing by a certain amount. So I think we have to allow owners to control well, to own that last few meters. And the control thing comes in a bit later in terms of what's happening. If you go down this route of separating out IP and Ethernet, owning your last few meters of fiber, having different stages, what you critically need are more neutral interconnects. Okay? You have to break that end-to-end circuit control, and you have to allow different segments of the physical network to be invested in and owned and controlled by different people along the chain. So I have to be able to own my last 10 meters and splice that or connect that at a neutral point to the regional fiber that runs past my road. And maybe that connects at the school. And maybe at the school it connects to a variety of service providers, and we can do micro-peering for services. Okay? And what that means...
I'm sorry, keep in mind that we have only about 8 or 9 minutes left, so we need to pick which of the remaining 3 topics you want to focus on.
Right, okay, we'll do that very easily. So here's some potential attributes of that service. Clear distinction between direct or on-net services and indirect services. Commodity internet just becomes some sort of CB channel 19 radio. And the minute something becomes of value, you just micro-peer locally, and you take that service on your network last leg from that person at the local micro-peering exchange. So we almost bypass net neutrality simply by the service providers themselves have their own network layers. Okay? Resource efficiency. I'll skip through some of this sort of initial stuff, and I want to focus down on the energy a little bit. We all want to share nicely. We want to use less. Okay, so the advanced networks really push sharing people. Video conferencing is a big thing. The higher definition, the better. If you've not tried high definition video conference or you don't have it at Google, you really should. Standard definition, 640 lines or whatever PAL in the US NTSC is just no good. You really want to be at 720p or above. And the difference when you're operating with people around the world in terms of seeing their face, just remarkable. Sharing data, we talked a little bit about this earlier as well, so I'll skip past it. But we do need to be building in data considerations that's slightly distinct from intellectual property considerations into research contracts from the get-go. Okay? And we need to be supporting those data curation efforts. Sharing kit, well, that's fine. Okay? You just network enable it. You sit at the other end of a big pipe, and you decide to control the tsunami wave pond from the other side of the Pacific. Okay, so you've got your place down in Auckland, New Zealand, and you're running experiments in a large-scale physical kit somewhere else in the world. And that stuff's happening already, and that's great. You get really much more efficient investment in research capital. Cloud computing, maybe just spend a few minutes here. From cluster to cloud. You asked earlier what's driving this sort of stuff, and it's that combination of scientific desire and things getting more expensive and the fiscal constraints that are going on equipment that's sort of driving some of this utility computing. I think clusters are going to be around for a while, the cluster under your desk or the cluster in your server room at the university. But interestingly, in the last year, we're really seeing the commercial world, and by that I mean the sort of IBM, Google, Amazons, I would actually want to say leading some of the academic world in this sort of cloud computing space. The University of Washington course that IBM and Google have set up around cloud computing. Okay, and distributed infrastructures. Potentially your sort of research.google.com data archive. Okay, again, cloud repositories for data. Of course, Amazon Web Services are getting a lot of play in our community. Okay, now they've added on SimpleDB as well. That's turning out quite a potentially attractive research platform for those people who need some supercomputing but don't really want to get into the business of owning or trying to run a supercomputer. So there's some real opportunities there, I think, for the commercial sector to be working really closely and actually driving some of the possibilities in the research sector. There are challenges, though. I think interoperability between providers, the ability to take my data out to move it to another provider. We see the same challenge on social networks. How do you move your MySpace profile to your YouTube, to whatever, right, to your Facebook profile? Same thing happens with these. The minute you go to the cloud, you need to have some sort of standard way to get your data and move it between services. Now, that decreases profits because it decreases your lock-in and your commercial attractiveness, but it's pretty important, I think, for wider take-up. I won't go into these, but I'll leave these slides. Obviously, they'll be online. And Ian Foster's a Kiwi who works in the US and is sometimes called the father of grid computing. But he wrote a post just a couple of weeks ago on where he saw cluster or cloud computing going. And I think critically, he aligned it with where he thinks the future of energy is going. A mix of micro production and processing and large utilities, and somehow dynamically load sharing between them. And I thought that was interesting. He wasn't plumping for one or the other. He wasn't plumping for massively distributed. He wasn't plumping for massively centralized. He was actually saying there'll be a mix. We'll have big power plants generating big thermal energy supplies and big nuclear supplies, and we'll have some distributed wind and solar as well. And how we actually sort of tie those together dynamically, there'll be similar problems. We'll skip that for time. Carbon neutral computing. That's obviously a big topic just now. And people are starting to locate data centers next to hydro stations in Iceland. More and more people are trying to say, well, let's have a carbon neutral ICT infrastructure. We don't know what price carbon will be, but it's pretty fair to say that carbon is going to be more expensive, right? Here's just a raft of different estimates, recent estimates in terms of where the price of carbon will be. And if right now it's 20, 25 US dollars a ton, then it's certainly going to be, well, they reckon at least $60 a ton by 2050. Maybe a lot higher. So we do need to take care of this just now. I think there's an opportunity for New Zealand here, though. New Zealand government set a target to be 95% renewable by 2025. We'll probably get there, maybe 90%. But already New Zealand on average has, what, 70, 75% renewable energy generation. So, one of our potential business models is to swap metal for data. Right now in the very south end of the country, we have an aluminium smelter that has its own hydro power station, right? Consumes about 15% of the national grid power in New Zealand, right? And I reckon, I did some research, it's about 6% of the global 2005 data center energy requirements for the world, well, global world. So maybe New Zealand, yeah, it's got some latency issues there, but in terms of maybe non-real-time and non-interactive stuff, we could close down an aluminium smelter and sort of host 5% of the world's data, right, in a carbon neutral manner. I do think that we need to go beyond carbon neutrality. Our ICT, 2% of global emissions are from ICT. So we spend a huge amount of time, we become carbon neutral, and we've had 2% impact, right? I mean, why bother? We need to be carbon negative. So we need to be driving ICT and networking technologies towards a point where, whether we're measuring bits per carbon instead of bits per second, but we're basically not just being carbon neutral, being carbon negative. And that's going to come in odd ways. This is a survey from Telstra in Australia. The biggest impacts from ICT technology weren't the standard stuff, teleworking, video conferencing. It was demand-side management of energy requirements, right? So ICT is not about just making the infrastructure carbon neutral. It's about making the world carbon negative. I'm very conscious of time, so what I might just do is pick one slide out of this section and one slide out of the last section. And if there's any last questions, then you guys get back to work. We have driven practical policy changes in New Zealand, but I won't talk about those. This is briefly, I want to dwell on this. We're seeing a lot of talk about virtualization of network resources in our community. So this is about taking network substrates, which could be owned by multiple different domain owners, okay, and putting in control planes, which effectively allow you to create end-to-end, so that's end user to end user, on-demand virtual networks, okay, across them. So you're not going in and provisioning a big IP circuit or configuring a router, to have a big sort of, BGP session set up, get yourself a new ASN. You're simply saying, I would like to talk from here to here. I don't care what it goes over, okay, and dynamically I'm going to provision an end-to-end circuit. It's almost like back to a telephone call. It's like back to POTS, right? But over multi-domain network substrates, okay? And without going into a lot of detail, I think this is going to be a big focus. I think we're going to get a shift away from some of the IP router configuration focus of networks and on more to the resource management, control plane management layer and down to the physical layers. Okay, and this is a big challenge for the REANNZ networks going forward. Exactly how does this work? There's lots of people doing things. The EU is spending a lot of money in this area and more. People are saying, well, we want to just wipe the existing internet clean and start again. The US is saying we need a Genie program to do that. The EU is saying Federica is going to be the way forward, and they're all sort of saying we might work together, but we're not quite sure what we're doing and when we will work together. So this stuff is still to be determined, but it's all related around this, what do networking resources mean and how will they actually respond to the future? Look, and the last slide is basically, we try and support some of our companies as well and get them onto the local stage. But what's critically important for New Zealand is telling our stories. New Zealand has an amazing history, amazing culture that is quite different to a lot of other places. It's very Pacific, it's very Western, and it's actually quite modern. But we have increasingly large amounts of cultural resources online at ever higher media specifications. And right now, it's quite limited to be able to get to those. Once Karen's in place, once you've got some great educational institutions, taking the lead, everyone around the world, everyone around the Pacific will be able to have much better access and much better understanding of New Zealand, just as New Zealand's going to be able to have a much better understanding of the rest of the world. Okay, that's me.
Thank you, Donald.